Okay, these are the solutions for the mean value theorem homework that I think was Thursday night. This is from sheet 4108. So the question is, which one of these satisfy the conditions of Rolle's theorem? So first of all, the function has to be continuous, and if you look at h of x, there's a hole right here, so therefore that one's out. If you look at the other two, they're both continuous, and they're differentiable everywhere. And there has to be a place where f of a is equal to f of b. So if you look at this first one here, this was a here and b was up here, which is a little bit higher. So f of a is not equal to f of b, so that's out. And then if you look at the second one, a was located here, b was located here, so f of a is equal to f of b. So Rolle's theorem only holds for g of x, and that is choice A. Okay, here's number 2, and the answer was D as in dog. So for number 2, you were being asked which of these graphs do not represent the conditions of Rolle's theorem. So it has to be continuous, so that takes out this middle one because that's not continuous. It also has to be differentiable everywhere. And if you look at the third one, you can see that it's a sharp corner like a cusp, so that is not differentiable everywhere. And therefore, the only one that, and also it has to be f of a is equal to f of b. And you can see that the two y values are exactly the same. So therefore, it's going to be choice 1 only, graph 1 only. Wait, sorry, that's the one that it is Rolle's theorem. So which graphs do not represent Rolle's theorem? It's numbers 2 and 3, and that is choice D. Okay, for number 3, the answer was B as in boy. And so you were told that this is Rolle's theorem, so we don't have to go through that whole f of b minus f of a thing. We can just take the derivative and set that equal to 0. So x equals plus or minus radical 5 over 3. So first of all, the interval says it's only going to be positive numbers, so I know that it's definitely not going to be negative, so I'm going to take that out. And so when I look at these choices, it looks like radical 5 over 3 is not a choice. Just going to rewrite it like this. But if we rationalize that denominator, we get that, and that is choice B. Okay, so number 4 is going to be just like the previous problem. We already know it's Rolle's theorem. So I'm just going to change y into a nicer form. Oh, and the answer for number 4 was E as an elephant. Okay, so the derivative is going to be 1/2 minus 1/2 x to the negative 1/2, and I'm going to set that equal to 0. That'll make that look a little nicer. And then I'm going to take the negative term and I'm going to bring it to the other side. Okay, and now I'm going to cross multiply. Divide both sides by 2. And then to get rid of the square root, you square both sides. So you get that 1 equals x. 1 is in the interval from 0 to 4. So therefore the answer was E. Okay, for number 5, the answer is approximately 0.764. Okay, so this is Rolle's theorem, so I'm going to take the derivative, which is a quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. I'm going to set that equal to 0. Okay, I'm going to cross multiply. And I get that. Now I'm just going to do a little simplifying. I'm going to distribute this 2x. And now I'm going to distribute this negative. Okay, and I have two like terms here, this and this. And I get that. So this is not factorable. So you're going to have to use the quadratic formula or use your calculator. But if you put in your calculator, you're going to put that piece in your calculator. Then you're going to set the interval from -2 to 2. And when you do that second calc thing, you're going to get that C is going to be 0.764, which is in the interval. So that's the answer. Okay, now moving on to sheet 8486. You know, and I'm noticing that the first multiple choice, and I think this happened on the other one, was not what I had written, so I may have told you the wrong thing at the time, but okay, we'll clear it all up now. Okay, so this is number 1, and we want to know which one of these functions do not satisfy the mean value theorem. So there are two conditions of the mean value theorem. One says that it has to be continuous in the interval from a to b, including a and b. So therefore, it can't be this, and it cannot be this. Okay, the next part is that it has to be differentiable in between a and b. So the second one has a cusp, it can't be that, and that only leaves the third one. So one of them satisfies the mean value theorem, and 3 of them do not satisfy the mean value theorem, so that would be choice C. Okay, this is number 2 now. Again, it's a mean value theorem problem. So we're just going to go through the whole thing because we don't know if this is Rolle's theorem or not. So A is negative pi, B is pi. So f of A is going to be f of negative pi, which is going to give me cosine of 2 times negative pi. I don't know why I'm turning this into a fraction. Plus sine of negative pi. So if you don't have a calculator, you can look at the unit circle, and negative pi just means to start here, and instead of going in this direction, you're going to go in the opposite direction. So you're going to go this way, that way, and you're going to end up here. So it's the same thing as pi, it doesn't even matter. So this is negative 1, 0, cosine, and sine. Oh, this is 2 times negative pi. So that is going to be... Okay, well, let me do the other one while I have the picture. Okay, so sine of negative pi is right here. That's going to be 0. Okay, now I need cosine of negative 2 pi. Okay, so where is negative 2 pi going to be? Let me erase this. Okay, so 2 pi would be traveling around one complete circle like that. But if you're going to do a negative 2 pi, it just means that you start right here, and you're going to go in a negative direction, 2 pi. It brings you right back there anyhow. So this is the point 1, 0, cosine, and sine. So cosine is 1, so you get 1 plus 0, which just equals 1. So that's f of a. So I'm going to put that up here. Okay, I'm going to erase this. Okay, now we're going to look for f of b. Okay, so f of b is f of pi. So we're going to get cosine of 2 pi plus sine of pi. Okay, 2 pi is right here. and pi is here. Okay, so cosine of 2 pi is right there. It's going to be 1 plus sine of pi is 0, and so we get 1. So f of b equals 1. So now we know that this is Rolle's theorem because f of a is equal to f of b. So at least we don't have to use that whole formula of f of b minus f of a, blah, 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 because we know that that's 0. So we can just take the derivative and set it equal to 0. So the derivative of cosine of something is negative sine of that something times the derivative of the something. And the derivative of sine x is cosine x. And we're going to set that equal to 0. So you might want to just make this a little bit nicer. Okay, and you're going to put that into your calculator. You're going to put this piece in under your y equals, and you're going to put this in as your window, negative pi to pi, and you're looking for how many times does it hit the x-axis, and you should see that it hits the axes 4 times, so that was choice D. Okay, for problem number 3 now, it's talking about the mean value theorem and which of the functions would not satisfy the conditions of the mean value theorem. So remember, the mean value theorem says that from a to b, including a and b, it has to be continuous, and then in between a and b, it has to be differentiable. Okay, so after what we just learned in class today, I'm going to start with the second one. Do you see it has an exponent of a fraction? That means that there's going to be a cusp. That doesn't mean that you might not be able to find a value, but it just means you're not guaranteed a value on the mean value theorem because there's a cusp, meaning it's not differentiable everywhere, so you can take that one out. Okay, if you look at the third one, you have a 2x in the denominator. If x equals 0, then this function is undefined at x equals 0, and x equals 0 is in this interval, so therefore this one's not guaranteed. You might get a value, but the question is asking, is it like guaranteed by the mean value theorem? If you look at the first one, you have a 4 and a 2 in your denominator, so there's no reason why it would not be continuous there. You're not seeing any cusps there, so therefore it's just the first one. This was choice number 1, is the one that does satisfy it, and the question is asking which ones don't satisfy it. So it's going to be numbers 2 and number 3, and that was choice C. Okay, for number 4, I'm sorry, I keep forgetting to give you the answer beforehand. For number 4, the answer is E as an elephant. So for number 4, it's the mean value theorem, and when you see all the choice, it's all these crazy decimals, which is an indication that you're going to have to use your calculator for it. Okay, so A is 0, B is 2, f of A, let me just put it down here, hold on. F of A is going to be f of 0, which is sine of 0, because I'm plugging into this right here, which just gives me 0. So f of A equals 0. F of B is going to be f of 2, so I'm going to get sine of 2 squared, which is sine of 4. So f of B equals sine of 4. Okay, I'm going to erase this, make some room. So this is not Rolle's theorem, because f of A is not equal to f of B. Okay, sorry about that, I got a phone call. This time it was a different phone ring than the last one that no one even tried to get for the extra credit. This one's easier, so I'm not offering extra credit for that one. Okay, so here's number 4, and I forgot what we were at. All right, so f of A is not equal to f of B, so it's definitely mean value theorem and not Rolle's theorem. So we're going to do f of B minus f of A over B minus A, which gives us sine 4 over 2. Okay, and If you put that into your calculator, you get approximately negative 0.3784. So we're going to have to set that equal to the derivative of sine of x squared. That's right here. So the derivative of sine of x squared is going to be cosine of x squared times the derivative of x squared, which is 2x. I'll put that in front. And that needs to be equal to negative 0.3784. Okay, so you're going to get this set equal to 0 by adding. So that this way you can put this piece into your calculator. You're going to set your window from 0 to 2, and you're going to do that whole second calc thing. And when you do, you're going to find that x is equal to 1.309 blah blah blah, which is choice E. That was the answer for 4. Okay, so number 5, the answer is 25 over 4. So A equals 4, B equals 9, f of A is 2, f of B is 3. So f of B minus f of A over B minus A equals 1/5. Okay, you're going to take the derivative of x to the 1/2. So you're going to get 1/2 x to the negative 1/2 has to be equal to 1/5. Write it a little bit nicer, like that. And then you're going to cross multiply. And you're going to get that. I'm going to go up here now. Divide both sides by 2, and you're going to get 5 over 2. And then to get rid of the radical, you're going to square both sides. And you get x equals 25 over 4. That's equal to about 6 point something, and that's in the interval. So that's why that's the answer. And we have one more, which is number 6. Here's the function. Here's the interval. The answer should have been radical 3. So A is 0, B is 3, f of A is 7, and f of B is 37. So it's f of B minus f of A over B minus A. Gives you 30 over 3, which is equal to 10. So you're going to take the derivative, set that equal to 10. Subtract 1, divide by 3, and then you're going to take the square root of both sides, and you're going to get that x equals plus or minus radical 3. Except that the interval is from 0 to 3, so you're going to exclude the negative number. Take that out. I don't know why my eraser's not working. There we go. And so the answer is just a positive radical 3. And that's it.